Hello, my name is Raivis Jēčis. I'm from neighboring country, Latvia. I will speak in English. If somebody will have some questions, можно и по-русски, да? Если что, какие-то вопросы, можем и что-то по-русскому говорить, на литовском. Sorry. Gerai? Okay, I'll try to be quick because we have running out of time, so let's see. I will speak more about ground energy. Before that, I will just tell something about where we are heading, what are the mega trends, where we are going, what is the future in a little bit in construction industry, about energy efficiency, and a little bit about that. What are the mega trends? What we can see in the world, what's happening? We can see that the people are getting more and more. So there are more people in our small planet, and also we are getting older. Even if we are eating some not so really good food, yeah, as we are claiming, still the statistics show that we are living longer and longer. So there is a need also for retirement houses for old people. So the industry also for construction is also for older people. What else we can see? There's urbanization. That means that people are coming from countryside. There are not so many single houses somewhere in the woods. They are just coming to the cities, and the cities are growing bigger. This is also some kind of problem for cities that they are expanding. And the main point of today is energy. Energy, there is increase in energy, and the climate change. Okay, there are different opinions. Is there any climate change or not? But the study shows that we have to be careful with our resources, and also world is becoming warmer. Today, the energy cost, as you can see in a gas station, it's quite cheap. It's getting cheaper and cheaper every day, almost. Yeah, the gas prices. Also, the taxes are going up instead of energy prices. But that means that we have to make our solutions, like for heating and for cooling, energy efficient, to be prepared for the future trend that at some point the oil prices, gas prices can also rapidly go up. So we are prepared for these kind of situations. If you are looking a little bit in the past, that there was this policy set by European Union in 2008. It's like 20-20-20 by 2020. Yeah, some time ago. That means that the main goal was to reduce greenhouse gases like 20% from the 1990 level, and also the share of renewables have to be increased to 20%. That depends from country to country. That some countries are more doing in this field, that they don't have so many renewable resources like for example, Latvia has some rivers, and there is hydropower energy, so it's already quite large. Some 40% of energy is from renewables. For some other countries, it's not so much. Yeah, energy consumption has to be driven down. So actually, well, it's not so much time left till 2020. So let's see how it will be at the end. But the idea was quite nice. Hopefully we will get there. It's not much time left. If you look at the European construction, 2030, what can we expect? We can expect that there are a lot of existing buildings, old buildings, built in the times where energy efficiency was not so important or not so big issue. That means that there should be renovation of these old buildings. So that means that not so many new buildings, but old buildings will be renovated. Low energy house standard will be implemented. Also, near energy houses will be, for the new build, it will be like a standard. So you have to be very careful how you use your energy. And also, industry that works in this field will be quite successful. Is it renovation or is it renewable energy sources? That means this. If you are thinking where the future is, I think this is the future for the construction. And also the trends for construction. There are other things that will be important for the future construction. Material efficiency. We want to build quick, easy, also off-site production or prefabricated houses that are produced in somewhere another place and bring to the construction site will be more and more, not just existing state that there is construction ongoing on the project, on the object, but many things will be already produced somewhere in other place. Energy savings, CO2, green buildings, whatever we see with this green building, quality, design, style, it's all important things, and also lifecycle costs, how much energy it's needed to produce whatever, bricks, pipes, and this cradle to cradle, how much energy you have to spend to get this material, to get your, I don't know, iPhone, and then to recycle it, so the new phone can be made. More and more also standards and regulations will be in whatever, even for maybe chairs regulation, what kind of chairs and how comfortable it should be, even something like that. So this is a trend in construction industry. If you look at the energy consumption, it's a consumption from 2030 that we can still see that there's fossil fuels ruling the world, oil, coal, gas, and only 90% are renewable sources. The biggest share is biomass, wood, and this has to be increased. Of course, we live in Europe, and we are more concerned about this energy efficiency and so on. These are data for all the world. That means that if China, for example, where a lot of production ongoing, doesn't want to improve energy efficiency and also renewable sources, that ends up also in this energy consumption, that it's not so good for the world, we can say. What are sustainable energy solutions? There are, I guess, two main keys. Renewable energy, that means that we have to produce energy that we are using from renewable sources. Whatever, is it hydropower, that means rivers, say maybe waves in the sea, biomass, wind, and we should not only produce renewable energy, we should also think about energy efficiency, how we use this energy, how efficient is this energy spent. These are two main things. If we look at the new office buildings, it's interesting that for new office buildings, for example, this is building for Tallinn in Estonia. That was recently calculated with energy piles, and heating cooling loads are. We think that okay, we live in a northern climate zone. There's a winter, quite cold in the winter time, and sun is not so long. It comes and goes very fast. But we can see that the heating loads are much smaller than the cooling loads, even if the summer is quite short. That means that architects are still using glass facades and not thinking so much about cooling. Also, the regulation, I would say, that is more focused on the heating, to decrease the heating loads, not so much think about maybe cooling loads. And if you look at this building, for example, this is the bank in Riga. And what are the differences between these two buildings? I don't know if you can see, but this photo has been taken in summertime. You can see that there are trees with the leaves, and this is an autumn or maybe even in winter time. Maybe you can see that there are trees without leaves. And as you can see, these are blinds or curtains or jalousies. So the windows are closed. We build a nice house, glass house, and then we close it with the curtains or with the blinds. And then comes the winter time, and as you can see, they are not so open, even if there is no sun, like there's clouds, but still the windows are one half of that is closed. So it's funny that you build sometimes houses with nice view to see the river, but in the same time it's closed. And there comes this high cooling loads. So we have to think, if we are designers, to speak with architects to decrease these cooling loads. And if you think that this is only valid for office buildings, also new buildings like apartment houses, like it's there. For new apartment houses, there are also bigger windows, nice view. At least architects think that this is nice view. This is for new buildings. And if we take a look at some study case, this is also made in Estonia. I don't know why it's come from Estonia. So many things, but there was a case study in Estonia for new built apartment houses. That could be also a little bit related with renovated houses, like from Soviet times. We renovate, we put some insulation, and the studies show that if you increase thermal insulation, yes, for winter time it's better. It's more warm, but in the same time, in the summertime, it increases the risk of overheating. That means that the limitation in Estonia, at least it was 150 degree hours over 27 degrees. The limit is 27 degrees in apartment houses, residential houses. And there were measurements in 16 buildings. I don't remember how many flats, simulation in 75 flats. And the results show that there is there is this 150 degree hours over 27 degrees was increased in 94% of the flats. That means that flats have been overheated in winter, in summertime. There was too much heat. That means also that even for apartment houses, for well-insulated apartment houses, there is a need for cooling, because in summertime it is a problem that you have quite hot. And what we see, how it's done nowadays in apartment houses, it's like the normal case. It's like you put radiators under each window. This is a normal case or ordinary case. That is how it is built. Okay, from manifold or from risers, that doesn't matter. Sometimes it looks like this. Okay, it's not under the window, but these radiators, well, you put radiators and then you put something like that, because it doesn't make sense. Or you can see that this is, yeah, very good, very nice. A lot of heat coming out from the radiator. Or you make it like this. I also noticed, I was driving the bus here to Vilnius. I saw some buildings that it was built like that also. That there's a big window and then you put radiator. Just in case, yeah, it looks nice. Yeah. Or something like that. There's a balcony, you can even not see anything, but still there is this funny white box that takes space. How to handle it? The one way is to put underfloor heating system. Underfloor heating system, and also that works like underfloor cooling system. Then you avoid these white boxes in front of your windows. You can use cooling, heating. It's more efficient, more comfortable, and doesn't take space. And you can use low temperature heating system or high temperature cooling system. Also, there are some studies from Denmark about summertime. This is the house without external shading, no external blinds, nothing, just the windows, and different kind of cooling system, ventilation system. These lines represent the ventilation system with night cooling or without night cooling system, and this line is underfloor heating, underfloor cooling system. That means that yes, if you use this underfloor cooling system, you can radically decrease the need of the cooling, and you can feel better in day or night. This is with external shading, 50%. There are some shading, okay, is decreased. If you look at the graphs, it's slightly decreased, but still there is, if there is no active cooling system, there is still some time that the temperature is higher than needed. Okay, let's go more into the topic of ground energy, heating, cooling with energy piles. That's a little bit common with ground probes, but today I will talk more about energy piles. What we know about ground energy, what are the influencing factors that influence how much energy can we get out of the ground? These are climatic conditions, annual temperature in this climate zone, that means in Lithuania, what are the rainfall, how much rain goes how much water goes into the ground. Solar radiation, how much energy is flowing from the sun to the ground. Ground conditions, type of soil, what kind of soil is it? Is it a rock? Okay, or not so rocky soil. Is it the sand? Is it clay? These ground conditions. What about the groundwater? How high is the groundwater? Is there any flow of groundwater? Is the water flowing, or is it just staying there? Surface conditions. That means how much the surface is overbuilt. Is this building somewhere in the middle of the city, so there is no real solar radiation, or it's just a separate building like some warehouse or outside of the city? These kind of things all influence how much energy can we get from the ground. When we are talking about ground energy, we are talking about level to the ground, like ground up to 400 meters. This is called ground energy. If we go deeper, then it's another thing. And we can say that temperature increase in the ground, if we go deeper and deeper, is around 3 degrees per 100 meters. That means if we can go deep enough, there's a quite warm water or warm soil underneath. Worldwide surface temperature is approximately 30 degrees, and it's the same temperature if we are looking at temperature, how it's reacting with the sun. Then it's reacting like first 10 meters, 15 meters, then the temperature deeper is almost the same, winter time and summertime. Where to use? What kind of energy? What are the emitter systems where we can use this ground energy? As you, I think, know that the best way to use this ground energy is it's a low temperature energy, is to use cooling and heating systems that needs high cooling temperatures, like underflow cooling systems, ceiling cooling systems, or relatively low temperature heating systems like underflow heating systems. These are very good for the ground energy to get high efficiency, to get high efficient system. Energy piles. Energy piles are the piles that you put under the building. That means under the building here. Also, you can use slurry walls, or somebody calls it diaphragm walls. That means that these walls, or sometimes you can even use also some. If there are some tunnels, you can put the pipes in the tunnels and use this energy to heat up or cool your building. So the primary circuit is the absorber pipes, the pipes that are put in the ground, connection lines. That means from the energy piles to the manifold or distributor, heat pump, and then is your secondary system, whatever it is, fan coils, cooling ceiling, or on the floor heating system. That's the scheme of this, how it works. Heat pump, yeah. I guess majority of you know how it works. So there is a compressor that compresses the gas to the liquid state that generates heat. There is a condenser that gives heat to the heating system, and then we are taking this heat to the building. Expansion valve, so the liquid expands. Expansion needs energy, and we are getting this energy from air, from water, from soil. This is where we are getting our energy. There are different kinds of how the heat pump can work. Only in heating mode. That means we are getting energy from the ground using electrical energy and heating our system. Cooling. That means that we are putting the energy from the heat to the ground, regenerating the system. And if it's like fan coils, you cannot use passive cooling, you have to use active cooling. This is not very efficient, but also we can do it like that. The most efficient way is passive cooling, that we use only electricity of the pumps to circulate the water in primary circle in the ground, and in secondary circuit, that means in a building. And also we can use heating and cooling mode. Like some rooms might need cooling, like some conference rooms, like, I don't know, is it working now, but maybe we are cooling now this room, and some other rooms are heating with this energy. So we can use both these functions. As I told, the passive cooling is the best way. Have to use this kind of ground energy source. That means that we are using just electricity for circulation pumps. That means very low operating costs, also minimum additional investment costs. It's very environmentally friendly, and we can increase performance factor of our system. So this is very good way how to use the ground energy, to use passive cooling system. The working principle is initial situation. This is a building, the piles. Then is the cooling in the summer. We are cooling our building. Heat is flowing to the ground. So it's fall, autumn, it's heated up, and then there's a winter time when we are getting the heat from the ground. So these are the steps. What are we doing? Energy pile. What is energy pile? How to use it? We are not putting energy pile as like we have to use. We are just using the same piles that are used by construction, that are used for the building. What we are doing, we are just putting the pipes in the pile to get the energy from the ground. So that means that we have to look at the design of the piles from a building constructor and define which pile will be used to get the energy. Not that we are saying that, okay, we want to put these piles like that, and then you build your building. It's just we have to see what the building constructor gives us. The main way how to use it is to use it for heating and for cooling. That means heating in the winter and cooling in the summer time. This is the most favorable way how to use it. If we want to use it just for the heating or just for the cooling, or the cooling loads are much higher, then we should look what's going on with the groundwater flow, is it changing? If it's flowing, then the regeneration is going faster. Then we can use this flowing water for our needs, for heating or for cooling. The length of the pile should be that it's economically good, at least 6 meters. If it's less, then it doesn't make big sense to use these piles as energy piles. Yeah, cooling, as I said, temperatures as high as possible, and heating as low as possible. What factors are influencing how good the system is working is the heat flux, heat delivery to the pile, so the soil, how fast the heat or how fast the ground around the pile is regenerating, how fast the energy is flowing to the pile itself, how it's built, the pipes, heat pump, of course, how efficient it is, and secondary circuit, what we are using for heat, like heat emitters or cooling, for cooling. This all ends up how good our system works. Calculations, if we are talking about how much energy can we get from the pile, that means that for heating, if the pile is less than 60 centimeters in diameter, for the heating mode it's around 40-60 watts per 1 meter, or it's just a very rough numbers, or it's around 80 kilowatt hours annually. For example, heating, what we can get from the pile. For the cooling, it's 20-60. If they are bigger piles, then we are not talking about meters, we are talking about square meters. What is the surface area of the pile, and how much energy can we get from this pile in this case. Diaphragm walls or slurry walls that are put in the ground, it's around 30 watts per square meter with what we can get from this wall. For base slabs, what is base slab? Sometimes we can use also the slab under the building, the basement. We can use also this flat slab to use the cooling and the heating. Then it's not so big numbers, 10-30 watts. If the calculations, if the load is quite high, higher than 30 kilowatts, then you have to know what is the soil, how it's the heat conductivity about the soil, and the best way how to know it is to perform thermal response test. That means special machine, special equipment that's been used to circulate heated water. We put the pipes in the ground, we circulate heated water and see how much energy is going away, how is the heat conductivity of this ground, and how much energy can we get from the ground. This is the best way how to assess how much we can get from the ground. Energy piles, how can we build them? The most used way is this, the most simple. These are more sophisticated and doesn't bring so much energy that makes the effort. So this is the best way how to put the pipes in the piles. There are few ways how to do that. The one way is to put the pipes in this pile on site. So there are some pipes in the piles, or if you use kind of installation, ram or press pile, then you can put the pipes in the pile already in the production. There are just you may see that there are pipes put already on the production of the pile. Other type of installation is to put this in the ground and then fill it up with the concrete. For calculations, we can use special programs, special software as Energy Designer, where we put the energy demand, heating, cooling. That means that we need to know how much energy is needed for the heating and for the cooling, and it would be good to have on monthly basis. That means how many kilowatt hours are for heating in December, in January, in February, and also the same for the cooling. And then we can make some diagram of the heating and cooling loads. Ground properties, conductivity, what is the ground, thermal heat flux. You can see different cities, also Lithuania is there. Collector field, how the piles will be put in the ground, what is the distance between the piles, these kind of things. How the pipes will be put in the pile, what is the diameter that we can put in the calculation software. And then we can see what will be the temperatures in the piles, considering the loads, how much energy should we get from the ground, and also adjust these loads to these piles that we have in the ground. That means that if there are tall buildings and not so many piles, that means that we have to decrease this energy that we can get from the ground, and we must put additional district heating systems or chillers to be able to cool or heat our buildings. And here we can see that these are temperatures in the summertime for cooling and for heating. What will be the temperatures in the ground? And lastly, some pictures how it's done in real life. Yeah, some real projects, PEX pipes, different diameter of piles. Yeah, you can see this is a pile in the middle, and there are supply and return pipes going to manifolds. Yeah. Some more projects. Yeah. This is how it looks from the drawing. The manifolds, the piles. Some nice pictures from the projects. Also, these kind of energy walls, you can see the pipes. This is 26 meters deep, and that this is put in the ground to get the energy. So last point. Why energy piles? This means low energy today and also in the future. No one knows what will happen with the prices of the energy. Passive cooling is available and can be used. This is good sales argument to rent the premises or sell the premises that you have prepared for the future. Energy class can be better, almost maintenance-free system. There is no moving parts, and also this is free publicity. That means that we are green and we are supporting this green energy and saving our money. Questions? Вопросы? Окей. Слишком тяжелые, да, такой, да? Нет вопросов, да, слишком...
Ačiū, Raivi.